Hi everyone, in this video we will be learning about what are embeddings. Let's say we have some document and it was a very big document. We divided the document into small chunks. Now we need to convert these chunks into embeddings. Embeddings we can also call vectors, which are basically mathematical representation of the meaning of the word. Let's say we have, so for example, if we think of some word, let's say dog. Dog can be converted by a embedding model into 0.8, 0.2. This model only outputs in 2D. Now a puppy, which is also very similar to dog, can give you an embedding of 0.7, 0.3. This is just an example. The real world embedding models outputs in 768, more than 768 dimensions. There are various types of models available, various types of libraries available. Now the more the complex embedding, more the number of embeddings, more the number of dimensions required to store it. And let's say car is very different from dog, so the embedding will be very different and it will be very far from dog. The dog was 0.8, 0.2, and car, we will see a very live example how the embeddings are generated moving forward. And let's say vehicle is also very similar to car, so it might be, the embedding might be similar. So as we think, like, they capture the meaning. Embeddings are just a numerical representation which capture the meaning of the actual words or text. It can be images, it can be documents, it can be anything, but they are actually the coordinates in a high dimensional space. And if two words are very similar, two texts are very similar, two documents are very similar, while after converting to embeddings they will be stored very close to each other. So this is the embeddings. Now in traditional search, what we do is, like, let's say we have 10 documents and we want to search for some word in those documents. In traditional searches, the keywords will be exactly matched. And let's say if we asked for car and the document, some document have the keyword automobile, but it won't be matched because there was no semantic meaning involved in it. It was just exact keyword search. Car was present, then the document would have came. Otherwise, the document will never come. But here in RAG, we think about semantic searches. Now, semantic understands the concept as well as the context. So, if we say car, if we say vehicle, if we say automobile, all of them are kind of similar kind of things. So, once if we search for a document or a word related to car, the word that context or that document will be arriving. It has a human like understanding, as we see. So, for an example, if I say I need help with Python loops, in normal traditional search it will think of words as I need help with Python loops. So if some document have these words Python loops, it might give you an output. But if it does not have it, it won't give it. But in semantic search it will think about iterations, for loops, while loops, list comprehensions. If any document if does not have the word loops, it can might be the output, because it might be thinking, it might be meaning of that words Python and loops might be available in the document. So now there can be various types of embeddings. As we thought, the input can be text inputs, it can be documents, it can be sentences, it can be images, it can be audio, it can be videos. Everything will be converted into embeddings, and embeddings, as we thought, they are called vectors, which are the mathematical or numerical representations on which captures the meaning of actual word, sentence, document. We will be taking a very simple example where we will be dealing with sentences. So our first embedding, this is the code example given, the same code I have used in my Python project. If you copy from here, or if you directly, I will share the code with you, or you can directly refer it from here. So for example, here as we see, right, for example, I love programming in Python is the text. Now we are using, for this example, we are using sentence transformer, one of the library, static library, which we will be using, and the model is all MPNet base v2 to convert the text into an embedding. For example, the text is I love programming in Python. Here we pass this text inside the get embedding function, which will convert, encode this text and return as a list, that will be the vector for which. So for example, if we print the text, it is I love programming in Python, and the length of embedding, this model is using 768 dimensions. Initially we learned about 2 dimension, but in real life the dimensions of every word, every sentence will be very high, so that it actually captures the real meaning, and closely related sentences are stored together and different meaning sentences are stored differently. Now the first five values here we are printing, and these are in decimal numbers. Now moving towards similarity. Let's say we have few sentences. I love programming in Python. Python programming is my passion. So if you can see clearly, right, a human understands that text 1 and text 2 are very similar. But text 3, I enjoy cooking Italian food, is very different from text 1 and text 2. So if we convert the embeddings of all these three and we find the cosine similarity, I will come towards what is cosine similarity, but if we find the similarity between embedding 1 and embedding 2, and print their values, we can get that the text 1 and text 2, the point values is 0.850, and the text 1 and text 3, which are not very similar, we 0.360. If the value comes close to 1, that means they are very high similar, and if the value comes close to 0, that means they are less similar. So before moving forward, yeah, this is the example of documents. We can have multiple documents, and if we find, let's say if the query was what programming language is good for AI, these were the already existing ones. Human can understand that okay, this is the one, but human will not be able to understand if the documents are very big in sizes, and if the document size exceeds 10,000, 10 lakh kbs of data, gbs of data, mbs of data, then it will also be difficult for human to find the actual AI like basic concept which can be fed to the LLM part. So moving forward, we can try this example. I'll show you a quick example in Python. So this is the embedding generation code. I will share this file. Let's say we have something like the same example, and I have ran in this project using the Python command, normal Python command. So let's say we have this model is loaded. Now if we have I love programming in Python, we converted it and we printed the first 10 values. This is the embedding which we get. Now if for multiple things, if we convert, again these are the five sentences which are these. Like these are the five sentences. I love programming in Python. Python programming is my passion. I enjoy cooking Italian food. If all these are converted into dimensions, embeddings, these are the dimensions. Now if we find the cosine similarity between them, as you can see, text 1 and text 2, which are actually very similar, Python, it has 0.8503. But if you see text 1 and text 3, I enjoy cooking Italian food and Python programming is very kind of different. But there are keywords such as I love, I enjoy. So it has some kind of similarity, 0.4610. But then machine learning is fascinating. Now this one and the first one, I love programming in Python, or yeah, one text 1 to text 5, sorry, my bad, cooking pasta with fresh herbs and I love programming, there is very less similarity between them, and hence the number is 0.397. Similarly, like this, now text 4 and text 5, if we see, machine learning and fresh herbs cooking pasta, there is no similarity between them, the model gives us a negative value. So these are the various examples. Now it is actually capturing the meaning, and when we are finding the cosine similarity between them, the cosine similarity is just that we get the vectors for both of these and multiply them, we get a dot product. This is a mathematical formula which we use normally in this, and to find the similarity between two vectors, whether the vectors are close to each other or not, and then we normalize the vector 1 and vector 2 and then divide the dot product with the multiplication of normalized values of 1 and 2. This is a mathematical formula which we use here. Now similarly, if let's say we have multiple documents and we need to find for a query of user, let's say the query was something like generate what programming language is good for AI. We know out of these 6 documents, some things will be matching with AI, such as machine learning algorithms is one, deep learning neural networks might be another approach, or data analysis using Python pandas. Now depending on how many documents we need, we can actually think for something like this. So let's take an example. What programming language is good for AI, and let's say we find the top 3 based on the similarity with everything. We got to know, okay, yeah, these are the similarities, and these are the top 3 similarities. There will be always some similarity between two documents, since these are characters, alphabets, there will be some similarity, there will be some meaning which we can say are similar. But for example, now again, how to make delicious Italian food, there were 3 documents: Italian cooking, traditional Italian recipes, and then this cuisine with olive oil. There was some kind of similarity. So yeah, as this was highly similar, the value is 0.7182. Similarly, these were the queries. So now Best practices for data analysis. Again, data analysis, there were some documents which were related to data analysis. Machine learning is also somewhat related to data learning. And then there was one document which was dealing with data science and machine learning. So again, this is the case. So these are the embedding examples. I hope you would have understand what is embeddings and how embeddings help in capturing the meaning of a sentence in mathematical format. And similarly, now the next time where this came into picture, we thought that when something is being asked to LLM, we will be using this embedding model. Like we would have got the company's document, we have converted those documents into chunks, and using embedding models we would have converted those like these documents into vectors, and then we would have stored all these things into a DB. Like here we have very limited example, like only there were 6 7 documents, so we were able to store them in memory and we were able to find them one by one. But in real life we will have lakhs of document, GBs of data, and if we store everything in memory, it will be very slow, the system will become very slow.